So that these are a special motor control circuit with dynamic braking. You see this component here. This is an SCR, silicon control rectifier. The thyristor, its job is to convert DC to AC to DC. It converts AC to DC. The AC signal coming from the power line is taken to this SCR. Yeah, this is also an equivalent of it. We have a type for electronics, a smaller type that is used in electronic circuits. This board is a TV power panel. Okay, so the same type is what you have here. It has 4 terminals. This has 4 terminals. That also has 4 terminals. It takes in AC and brings out DC. So we are going to be injecting DC into this 3-phase AC motor for dynamic brake. Okay, so you observe the circuit very well. This is the circuit we have. When we scroll down, we see the SCR. Okay, this is our SCR. Yes, this is the SCR. That's the SCR. So the SCR is going to take in AC from this line and this line. It's going to be, because it's taking 2 live, so that will be 415, single phase 415, 2 live. So it's going to rectify the AC and convert it to DC. So here is positive and here is negative. So it injects it through this auxiliary contact of the contactor KM2. We have 2 contactors there, contactors KM2, and send it through the it passes through the motor from behind the overload. Okay, so we have various components into play here. We have, can I zoom this thing out? Of course I can zoom it in for clarity. Okay, so let me clear this. Okay, so I have my SCR, my circuit breaker, my contactor, my overload, and my 3-phase motor. I have my brake push button, my stop push button, my start push button. Then I have my contactor coil KM1 and contactor coil KM2 with 3 LEDs. That's running, which is green, stop, which is red, brake, which is amber. So I've also introduced another circuit here for the fault. That is yellow. Okay, so I just chose to do that to indicate that there for yellow. So this is exactly what's in this circuit that we implemented in this. So we still have our 2 contactors, KM1 and KM2. So we are going to be using this 4-pole breaker to test it. If you observe, while we start the motor, it runs smoothly. Once we press start, this red light will go off and this green light will come on. So it's going to switch. So it starts smoothly and stops smoothly. Once I press stop, the green light will go off, the red light will come on, and the motor stops. So let's do that. Okay, but if I want to use dynamic brake, I'll have to press this push button to brake it. So I'll press start again. If I want a smoother braking, I can decide to press stop, then brake. It gives me a moderate brake without having any spark. But if I want to brake it suddenly, let's say you are running a conveyor belt and somebody is stuck on the conveyor belt and you want trying to save the life, so this circuit is beneficial in order to stop the operation so that you can rescue a worker that is trapped in a moving machine. The moving machines are actually powered by electric motors, so this kind of circuit is efficient. So this SCR is going to inject DC current to the electric motor to suddenly stop it. That's instant stop. So let's run it again. You observe the circuit box of the motor. You're going to observe a sudden jump or spark because of the DC that is coming from this SCR. Don't forget that this SCR is taking single phase 415 volts, 2 live. So it's a high DC volt that we inject on it. It is powerful enough to stop this electric motor. So let's press stop. You see that? So it's a sudden stop. Okay. So this is a 2.2 kilowatts motor with it's connected in star. The motor is connected in star. See, this iron bar is looping the motor in star. Okay. So when we look at it, we see that it's a Chinese made motor with a power factor of 85.9. It weighs that's written in Chinese. I don't understand China, but I can still understand some inscription there. We have a voltage of 280 volts at 4.9 amps, 50 hertz, IP, which is ingress protection of 44. So these are the things we could observe from the motor. It's still connected, so I hope you follow up with this short training. It's a very interesting one. My name is Jimo Adedatun, and thank you for watching. God bless you.